Professor Deb here. Welcome to Technical Mathematics. This video lecture is on exponential and logarithmic equations. Prior to this, hopefully you have viewed the lecture videos on exponential functions, logarithmic functions, properties of exponential and logarithmic functions. And now we'll talk about how to solve for x with exponential and logarithmic equations. So at any time, pause or stop the video to examine the material more carefully. Let's get started on this one. Here's some rules, some steps to help you try and solve equations. First of all, any exponential equation is contains an exponent in it, such as 5 to the x equals 25. Well, we would solve for that x. That is an exponential equation. We're later going to look for logarithmic equations. So use the properties of exponents to rewrite each side of the equation in terms of exponents with the same base. If you recall the earlier video, we started to talk about the base. Use the fact that x equals by can be rewritten as log to the base b of x equals y. So again, we're going to be going back and forth between the exponential type of equation and the logarithmic type of equation. And the prior videos talked about each one of these individually. We're going to be working back and forth. Now let me remind you that the common base that we work with is the base 10. That is the normal arithmetic that we work with, 10, 20, 30, 40, base 10. So we'll be working with that as well as looking at some other bases. So we're going to rewrite the equation so it's equivalent. And then we're going to solve the resulting equation. And that's the goal of this video, is to get you to understand how to solve the equation. Ready? Here's two equations. They're both exponential equations. Let me get something to write with. Okay, we have 6 raised to the y equals 32. Now, how are we going to solve that? How are we ever going to determine what y is? If we add log to both sides of the equation, let me clarify this first. If I add 1 to both sides of the equation, am I changing it? No. I can add, let me get rid of that 1. I can add anything as long as I add it to both sides of the equation. I'm not changing the equation, right? So let's add log to both sides. Let's rewrite this as log of 32. Now I haven't changed the equation, right? But if you remember, when we had an exponent here with a log equation, we could bring that exponent out to the front of the log and make it a multiplication. So now we can rewrite this as y log of 6 equals log of 32. All right. Now let's solve for this. We're using basic arithmetic algebra properties. To get y to stand alone, we divide by log of 6. I'll write that out just this one time to remind you how to do that algebra. This log of 6. So now let's rewrite the equation. And this is the format that I'll use in the future. So we have y left alone on the one side, and what we have left over is log of 32 divided by the log of 6. Now if you put that into your calculator, log of 32 divided by log of 6, you will get an answer that is about 1.934. So you've solved for y. Now look at, again, what we started with. Log of 6y equals 32. Would you have ever guessed that that number in the exponent would be 1.934? No, probably not. But you can solve it very easily by using the properties of logarithms. All right, let's try that again. We've got a little bit more complicated one this time in that we've got y to the minus 7 as our exponent. Okay, this time I'm going to rewrite this, but I'm going to use ln. I'm going to add ln to both sides. What was ln? You remember? Natural log, the base of e. Does it matter whether I add log to both sides or ln to both sides? We're back to that. Did it matter if I added 1 to both sides? No. Does it matter whether I add log? Does it matter whether I add ln? Could I have used log here? Of course. It doesn't matter, as long as you do the same thing to both sides. Now, we're going to take this exponent and we're going to bring it around in front. So y minus 7 ln of 2 equals the ln of 67. All right, somehow we got to get that y to stand alone, so let's do it very simply in steps. We'll take the ln of 67 divided by the ln of 2. Okay, we've got an equation that's stepping up here. All we have to do is reverse the algebra. So we'll add 7 to both sides. Ln of 67 divided by the ln of 2. And we have to add that 7, right? We add 7 to both sides to undo the algebra. So if you put that in your calculator, ln of 67 divided by ln of 2, I'll just put that in parentheses so you know to do both of those before you add the numeral 7. And you should end up with a value of 13.066 or something near that. All right? So you could barely see this equation anymore, but 2 to the y minus 7 equals 67. The answer for y is 13.066. Great. All right, can we get a little more complicated? Here we go. Now we've got x on both sides of the equation. So we're going to do the same thing. We're going to add log. Got to get my writing instrument again. I'm going to add log. I'm going to rewrite it down here because we've got kind of a long statement here. Log of 2 to the 3 minus 2x equals the log of 8 to the 1 plus 2x. Now, log of 8 can be rewritten as what? That can be rewritten as log of 2 to the 3rd. We don't want to lose our 1 plus 2x, so we'll just carry it for now. Okay, don't worry about the exponent on the exponent. We'll just carry it for now. Okay, so what we have is log of 2 to the 3 minus 2x. So remember, we can take this And we can bring that exponent down in front. Now we're going to bring that whole exponent down in front. I forgot my equal sign here. So we've got 3 minus 2x times the log of 2. And we've got 3 times 1 plus 2x times the log of 2. Those cancel out, right? Because it's the same thing on both sides. So now I've got a much easier equation to work with. 3 minus 2x equals 3 times 1 plus 2x. Let's multiply the monomial inside the parentheses. 3 minus 2x equals 3 plus 6x. And combining like terms, we're going to add 2x to this side, so we're going to end up with 8x there. We're going to subtract 3 from this side, and we end up with 0. So we put the 3 on this side and 2x on this side. So what does x equal? X equals 0. Alright. Ready to give it a try? Here's one for you. Stop the video and try it. Now let me give you a couple hints. You can add ln to both sides. You can add log to both sides. Doesn't matter, but you're going to add it to both sides. And then once you've got that, this variable, this exponent, comes down in front. And then you'll have a nice equation to work with. Okay, so stop the video and try this, and then check in the guided solutions. All right, now we've made exponent equations, and we've solved them using logs. So guess what we're going to do? We're going to take logarithmic equations, and we're going to solve them using exponents. All right, let's take a look at it. Use the properties. Use the properties of logarithms to combine all the logarithmic terms into one. Now we did that in the earlier video on properties. Now we're going to use the fact that log to the base b of x equals y is equivalent to x equals b to the y. This is what we've been talking about. We've been going back and forth between the log and the exponent relationship. Then, of course, solve for the resulting equation. So I'll try and keep bringing back the difference between the two steps, but I separated them in this video so that we weren't confusing each one of them. So let's give it a try. Here's a problem. Okay, it's already got that ln on one side. Now, remember we talked about ln being the natural log. And what was its equivalent? E. Right? The natural log went along with the e component. So if I add e to both sides, that means this cancels out. And this becomes y plus 3. Actually, I'm multiplying e to both sides. So this becomes y plus 3 e to the 19th. So y then equals e to the 19th minus 3. And unfortunately, I didn't put that in my calculator to find out the value of it. So you'll have to do that. But I think you get the idea. Find the E button to the 19th minus 3. And you get your value. All right, let's take a look at another one. Here we have that natural log again, but it's on both sides of the equation. So it makes it easier. Now, what we're going to do in this case is we're going to go back and we're going to make this into an exponential. Now, what happens with the number that's in front of the log or ln? It becomes the exponent, doesn't it? So we have the ln of x squared equals the ln, or natural log, of 4. So we can take the ln off, and what we get is x squared equals 4. Be a little careful here. Remember that when we have a square root, that can be a plus or minus 2. Okay, so just a little kick there. Plus or minus 2. Now, if it's plus or minus 2, I should be able to put that back into the equation. However, do you remember in the very, very beginning when we first started this mess, we talked about that negative 2 was not in the domain. X could not be less than 1, less than 0. So less than 1 actually. So it could not be negative 2. So your answer really is x equals 2. I just wanted to make sure we pointed that out, that we followed all the rules, that the square root of 4 actually is a plus or minus 2. All right? This is interesting. Now, at first glance, you think, oh, x minus 4 equals x minus 4. But that is not what it says. First of all, we're going to combine the logs. So we're going to say the log of x minus 4. Now we want to keep that in parentheses because it's the log of all of that quantity minus the log of x equals negative 4. Now, do you remember your properties of logs? What did we do when we had a log minus a log? It became a division, right? So we have log of x minus 4 over x equals negative 4. All right, now, this log again is a base 10. How do I get rid of log of base 10? Remember back, let's see, here we are. Remember, to get rid of the ln, we put its exponential, or e was the opposite of ln. Opposite's not a good word, but we'll use that for now. Okay, so now we've got the log, the common log. And what is the opposite, if you will, for the common log? It's 10. It's 10. So we have x minus 4 over x equals 10 to the minus 4. So that's the same thing. Let's say if I multiply by x, first of all, let's leave that. Let's just step it out. What is 10 to the minus 4? 0.0001, right? Okay. Now, we're going to multiply by x in order to get rid of it. So I've got x to the minus 4 equals 0.0001. Okay, combine x's, right? X minus 0.0001x, and I'm going to put this on this side. This is basic algebra. I'm going to combine the x's right here. There they are. And I'm going to put the 4 on the other side. We add 4 to both sides. All right, now what is, it's a little difficult to see, what is 1x minus 0.0001x? How many 9s do I need? 4, right? Okay. Divide by 0.999. I'm running out of room here. I'm sorry. Divided by 0.99999. That's going to be almost 4, isn't it? I think if you put it in your calculator, you're going to find out that x is actually equal to 4 point and a number of decimal places, and then 4. Make that a little clearer. So, long roundabout way a little bit, but actually what we did was we used the properties. We had log on both sides. So we couldn't just get rid of this log because we had a quantity here and then we subtracted 4. So we had a quantity. That was our problem. So what we had to do was bring the log over to the same side and use our properties that we learned in the earlier video to combine them. And then we solved for x. We used its inverse, we solved for x. Dividing by log over 10 is the same thing as 10 to the negative 4. Alright, that concludes our video and concludes the set of videos on exponential and